Hi, welcome to A-Level Further Mathematics Mechanics 1, and this is a new series that I'm doing. It's about the module in Further Mathematics for A-Levels, and mechanics is basically a lot of forces and basically physics. So today we're going to talk about the basic principles of force. So yeah, let's start. So there are a few things that you need to know. The first thing is that forces are vectors. They have a scale and they have a direction. So that is one point, and that will come quite obvious later on. And second, currently for Mechanics 1, you only need to know that forces will act on a plane, and that is on a flat surface. It won't have any angles between the opposite arrows, because opposite forces, because it's on the same plane. It's not going to suddenly turn, and just because that would come in, I think, Mechanics 2 or above. So you don't need to worry about that. And if that doesn't make half a bit of sense, then ignore this, because you won't naturally think those things, okay? And third, you need to be able to read questions, because most of the questions in mechanics are based on words and wordings. So despite some questions that in most questions in exams will give you diagrams to go with, but most of the time you have to interpret the data with by using the words. So you need to have a good understanding of understanding the question. Good English always helps. So yeah, let's go on for some exercise on drawing force diagrams. So you might ask me, what is a force diagram? Well, I'm going to talk through that now. Most of the time, a force diagram is just arrows emerging from a point. And in this example, I'm going to do one of these, which I made up purposely. And I hope that would help you to understand what means by a plane. So let's start. First of all, the question says, there is a particle that experiences forces. Well, we know that if there is a particle, it's probably a dot. Okay? So, yeah, I'm going to draw things on the screen. So that would take a while. So now we've got a particle. It experiences a 5 Newton force with bearing of 15 degrees. Well, we know that bearing starts from north, so due north is up here. Oh, this is terrible dotted lines. So this is due north. Sometimes it's good to have a thing like that and say it's north, okay? Oh my, never mind. So we've got a bearing of 0 currently, and what we need to do is to emerge a line from that particle upwards, 15 degrees from this northern point, and the bearing will be like right about here, I think, and that would be 15 degrees. Remember to label your diagram so that you know 15 degrees. This is terrible. Yeah, so now we've got one arrow. of 15 degree. This is the correct direction, but we need the magnitude, which is the size of the arrow. So it's 5 newtons, so just label 5 newtons. Okay, 5 newtons. So this is one arrow. You can try to do another arrow by yourself, and let's do 3 newton. So that is an arrow 3 newtons, which has a bearing of 75 degree. We know that this can go across 90 degree to eastward direction. So this is 90 degree. So we've got 90 degree, we just need to take away 15 degree from this point on. So another point will be from here out to about here. Yeah, roughly. And that would be 15 degree again. Okay, so this is taking a bit more effort than I think it's gonna be. So now what we know is that these two, I purposefully made this arrow short. Do you know why? Well, I said that forces are factors, so their magnitude relates to their length. The longer it is, the bigger the force. So this 3 newton will appear, 3/5 length of this one. Of course, this is like half length, but doesn't matter. It's just, well, I'm drawing roughly, okay? So the particle is here now, and we have another force, 210 degree. So the bearing will be let's see, because we know that this is 180, this is 270, and 210 will be I think right about here actually. Might be, yeah, but remember we have to scale it right, so it's 7 newton, it must be longer than 5 newton. You can use your ruler for assistance, and I don't have a ruler because I'm on computer, so yeah, that's unfortunate. And now we need to label the angles. So 270 is this one. So for 210 we need to minus 60 degrees, so this will be 60 degree. Well, I guess I drew that a bit off, but you know what it's all about now. And just label the force again, and you should get a force diagram. An important thing to note is that you actually don't need to draw a force diagram with information provided. The fact that I'm doing this is so that you can interpret the data given and to understand what is meant by like bearing and force and things like that. So yeah, let's go on to the second example. Actually, before I go to the second example, I have to say that because this is using bearing, it's a top-down view. So this is actually on like the top down view, the bird view, and there aren't vertical like up-down movements because it's on bearing, so it's always horizontal movements. So this is actually we're looking on flat plane, and that is just horizontal plane. that have 3 different directions. So yeah, let's go to the next one. So now we have a second example, and that would pretty much be, well, exactly the same idea, but this time it's a bit different. So I said here I have a 5 Newton force forward. Which way is forward? We don't know. Let's read on. We've got a 4 Newton force downward. Well, we know what downward is. There's only one downward. It's going down here. Okay? So this is 4 Newton downwards. That's the length, let's say. And 6 Newton force backward. Now we have a forward and a backward. So what can we do is we can draw forward and backward. Doesn't matter which is which, but remember the size doesn't matter. So in this case, I'm gonna label right hand side as forward. So let's write forward. Oh my, this is ridiculous. Oh yes, so we know forward is this way. So we've got the arrows labeled, and we know that because because we have a backward and downward, we know this is 90 degree. Okay, so that would make 90 degree, but problem is now a 5 Newton force forward with inclination, so this actually is wrong. What we need to do is to make an arrow upwards by 30 degree, and that would be sufficient. 30 degree. Hopefully you can read that. Okay, so this is actually the force, so this can be scrapped, or in this case I'm gonna make it dotted so that it's imaginary. You go away. So yeah, now we've got a horizontal plane and one force going up 30 degree, and that force we should label the size 5 Newton and downward 4 newtons and backward 6 newtons. I'm doing a terrible job at both labeling and determining the size of arrows, so if you have, try to use like 1 cm for a newton, or well, give it a scale anyways so that it's accurate, because well, forces diagrams need to be accurate, and you will know that in the future when I do well, spoilers, resolving angles, and that sounds a bit complicated, but I'm gonna explain that later. So now you know how to draw diagrams, and I'm going to test you with it. Practicing is always the best way to learn, and now I've got a few, well, 2 questions in fact, and I want you to draw the force diagram. So I kind of got lazy to write the whole bunch of sentences, so there is a 5 Newton force going to the east, and a 4 Newton force going to the west, and a 5 Newton force by gravity on a particle. So both questions are on a particle. And the second one is a 2 Newton force with a bearing of 275. Then the second force with 4 newtons, 45 degree, and a 4 Newton, 150. So that is those questions. So as usual, that's what I always do, is to count down 5 seconds for you to pause the video and do the questions, and I'm going to reveal the answer after the 5 seconds. So in 5, 4, 3, 2, 1. Yeah, I think I'm setting terrible examples here because the size of the arrows aren't to scale. Well, I blame that on the computer because I can make a specific length. So yeah, so hopefully you got them all right. Labeling is just well, you can do it quite vaguely. You can just do a 45 and 150 here. It doesn't really matter, and as long as they goes to the same bearing at last, it's not going to be a big deal. And of course, these are the northeast, southwest directions. So yeah, that's it for this video, and I hope you've learned something from this. And these principles will be shown really essential when you do mechanics very soon. And until next time, I'll see you in the next video. So see you next time.